But the last section is, we won't go to great details. Basically, just keep defining different functions. I mean, now you know that whenever you define a function, you can always derive a lot of property of that function, and that you could basically spend a whole lot of time for each function. But we'll just mention a few that because some of them are useful. So the first one is this incomplete gamma function. It's basically like the gamma function, but using the integral representation. But instead of integrating all the way to infinity, this is integrate to just x and e to the t a minus 1. Yeah. And again, there's but this integral representation has a limitation to make it converge at goes to 0, just like the gamma function. But you can extend it to the whole complex ring, right? And that is incomplete gamma function. There's one kind of incomplete gamma function, and there's a complementary kind, capital gamma x. Now it's the rest of the integral from x to infinity. This is minus, forget minus t. A minus 1 dt. Right. And obviously, if you add the two, you just integrate from 0 to infinity, it will give you back the gamma function. The one property to relate the two kinds of incomplete gamma function is this. You add back to the gamma function, gamma A. Okay, so basically separate the gamma function in two parts and depends on this variable x. Right, and again, there's many properties you can derive, and one property is I think you can just by some integration by part, because you have a variable x in the limit, you keep doing integration by part, then you get a series of x. So, but that's required that a is an integer. So that so one property is for a equals an integer by integration by part. Keep doing integration by part of this integral. You end up with this formula minus x sum over s from 0 to n minus 1 x to s. Okay, so that I mean I didn't derive that, but it should be pretty straightforward to derive from this to this, and then by this one, because if a is an integer, then gamma n, if a is n, is an integer. Gamma n is just n minus 1 factorial, exactly this one. And so this is this one, and then this plus that is equals to that one. So obviously, capital gamma n x is just the rest. This times that. Okay, so this incomplete gamma function in some sense is more complicated because now you have two arguments instead of just one argument, and the integral has a variable, the limit is a variable, but at least for some special cases, special value of A, it's just becomes like a power series, except you multiply by exponential function. So by this, you can see that the analytic form is not too difficult, like at least for this one. It's just usual exponential function and then power series. So that is kind of straightforward. But this is not very infinity become exponential function. Yeah. Okay, so it has some application. There's a little bit more what we just mentioned and other in the homework question also that you can work out. But it has some application. It depends on how you work on, and in my own research, I need to use this one also. And then need to consider its analytic property in the complex C-plane also. But anyway, these are the extension of the gamma function.